So let's try to solve these equations by modifying the base. Here's what I mean. Looking at this equation here, 25, 5, and 625, they are all powers of the number 5. For instance, 625 is the same as 5 to the power of 4. Let's leave 5 cubed the same. However, 25 is the same as 5 to the power of 2, and leave that power the same. Now recall this, power to power you multiply, so that's really 5 to the power of negative 2k times 5 to the third equals 5 to the fourth. And then recall that we can combine those two thingies into one. It'll be a single 5, but you're gonna have to add the exponents. So it'll be negative 2k plus 3. Leave this side the same. So we rewrote the bases as a common base to get to this point. Now I have one piece and one piece with matching bases. So in a sense, the bases disappear, and all we're left with is this exponent equals that exponent, which is why I wrote this down. You see that? This power equals this power. Now solve this equation. Subtract 3, so negative 2k equals 1. Divide by 2, and that's the answer for k. Up here, let's do the same thing. As a matter of fact, this is nice because all the 7s are already established. Now let's see. Here, I can put parentheses there, no big deal. And what I'm gonna do is instead of writing 2 7s, I'm gonna write a single 7. But what you have to do is you have to take the top power minus the bottom power. So that'll be 4x squared minus 8. And then the other side can pretty much stay the same, it's just 7, but I'm gonna put an invisible power of 1. And then because it's just 7 and 7, the 7s can really just knock out. So I can say this exponent equals this exponent, which is what this equation says. Now let's solve this equation. Add the 8, and now divide by 4. So we have a fraction. But now we square root, and since it's a square root, it is plus or minus. Now square root the numerator and denominator independently. And this equation has two solutions. If you wanted to, you can check your answer by plugging 3/2 in here and negative 3/2 in there. Both of these work out. So those would be those solutions. Where if you look at number 7, the first row, they mention a percentage of 3.12%. And it's going to be compounded quarterly. That's how you spell quarterly, right? And the investment is $5,000. And we want to know after 3 years. So time is 3 years. So here's what I would do. Using this formula, P is the initial amount, which in this case is $5,000. R is the interest rate as a decimal. So you drop the percentage by moving the decimal 2 spaces to the left. So it'll be 0.0312. 0.0312. T is time, which is 3 years. Here's the tricky part. K. K is the number of times that your money is compounded every year. They said quarterly. Quarterly happens 4 times per year. So for that reason, K is going to be 4. So let's write this down again, but let's make all the appropriate substitutions. So here's what I got. That's the initial investment. 1 is just part of the formula. That's R as a decimal without the percentage symbol. K is what we discussed. T is 3. Go all of this into a calculator, and the amount is it should be about 54.88. They did not tell us how to round, I think, unless I missed it, but it's about 54.88.6. So $54.88.6. That would be the value after 3 years. Now let me say this. In the next row, they said the word daily, and then they say monthly, and then they say continuously. Let me just throw this at you before we move on. Because they said quarterly for our problem, K was 4. If they say daily, If something happens daily, how many times does it happen per year? 365. If something happens monthly, how many times does it happen per year? 12. If something happens quarterly, how many times does it happen per year? 4, which is why we did 4. So when you get to these two problems, use 365 for K, for daily, use 12 for K when it's monthly. However, when it says continuously, you use a different equation. When they say continuously, you use this function here. So that you use when it says continuously, where P is the same thing, 5,000, time T is 3, R is the same decimal, and E is just a button on your calculator. If you look here, if you have a Casio, there's a button E, you have to hit Shift E, and it should be there somewhere on your calculator. So just find the letter E because E is just a number. But anyways, that's number 7. Now looking at number 8. So check it out. Here is, so they give you an equation, you have to tell them this, this, and this. So the number outside is the initial value, 1.4. Is it growth or decay? If the number in the parentheses is bigger than 1, growth. If the number in the parentheses is less than 1, decay. This is bigger than 1, this is growth. Percent change. So this is growth by how much? So the question you ask yourself is $1 or just 1.00. How much bigger is this than 1.00? It's 0.37 bigger, right? So 0.37 is the growth factor, but you have to turn this into a percentage. So move the decimal 2 spaces to the right, and you tell them 37%. This one here, the number on the outside is the initial value. Is this growth or decay? Well, in the parentheses, this is smaller than 1, so it's decay. What's the percent change? Well, how far away is this from $1? You can see that it's 0.06. You see that? You see how this is 0.06 away from being $1, 94 cents to $1. It's 6 cents short. Now just turn that into a percentage. Move the decimal 2 spaces to the right. It'll be a 6% change. In this case, a 6% decrease. So do that idea for all of number 8. And next time I'll make another video for more of those problems.